Hello dear student, I am Monroe Islam. Today in this video we are going to discuss important question from CSIRNET. This is a question from CSIRNET December 2016. The question from part C. Okay, this question is a 4.7 mark. 4.75 mark. Okay, what is the question? The question asking with n vector space, n vector space of n cross matrices which are interior. Okay, then which of the following are subspace? Among this, which of the following are subspace? So we are going from option 1, 2, 3, 4, 1 by 1. Okay, first see V1. V1 is a set. Those n cross matrices are in the set which is non-singular. Okay, non-singular means determinant non-zero. Okay, so we know if it's subspace, then zero vector must be in the set. Okay, and in this case zero vector will be nothing but the zero matrix, zero n cross matrix. Okay, this it is clear that this matrix does not belongs to V1. Okay, because if it belongs to this set, then it determinant should be non-zero, but it is determinant will be zero. Okay, determinant zero matrix will be 0. So this matrix cannot belong to V1. Okay, so since zero vector identity does not belong to this set V1, so it never be a subspace. So on is in that. Now we are going to option 2. Option 2 is V2. It is a set of all those even matrices such that determinant A is 0. Okay, it's subspace. So it is subset of Mn. Okay, it's subspace. No, it is not subspace. See, if I choose the matrix this 1 0 0 n cross matrices. Okay, it is n cross matrix, n cross matrix, and another n cross matrix B, this 0 0 0 1 each into 0. Okay, and this one diagonal is diagonal. First A1 is set A1 or is set A22, A33 and ANN are all integer 0. In this case A1 will be non-zero, all integer 0. Okay, so if I choose the matrix, it is clear that determinant this matrix will be 0. Okay, because if you break this matrix this row, then it gives 0. Similarly, determinant B will also 0 because this first row is 0. Okay, so determinant A is 0, so A belongs to B2, then B is 0, so B belongs to B2. B belongs to M2. Okay, then B is 0, so B, you can say B belongs to V2. So A, B both belongs to V2. Okay, A belongs to V2, B belongs to V2, but whether A plus B, I am taking this color, alpha will be 1 and beta will be 1. Okay, so you can say alpha A plus beta B. Okay, when alpha is 1 and beta is 1 is clear. So alpha A plus beta B means alpha A plus B. If we add A and B, see, this diagonality is 1 and this is 0. So if we add this 1 plus 0 is 1, and other diagonality is 0 and this is 1. This gives 1. This is 0. This 1. So if you add it, then this two matrices, then this gives diagonality 1. Means this diagonality 1 and all other diagonality 0. Okay, if you add these two matrices. So if you add these two matrices, you get this 0 1 0 0 0 1. Okay, this identity matrix IN. We all know this determinant is determinant 1. Okay, this is non-zero, so you can say determinant of alpha A plus beta B, alpha beta are 1, which 1 is non-zero. So this matrix alpha is linear sum alpha A plus beta B, this never belongs to V2. Okay, since this never belongs to V2, so you can say this is not subspace. Okay, so V2 is not a never be subspace. So option 2 is impossible. That. Now we are going to option 3. V3 is a set of all those even matrices such that TSI is equal to 0. Okay, see option 3. Option 3 is V3. It is a set of those matrices A M N such that TS is 0. TS means sum of principal diagonalities. Okay, for any matrix you can say for any matrix A N N, n cross matrix A1 to A1n, and AN1 AN2 AN. TS is nothing but a sum of the principal diagonalities. Okay, in this case TS will be sum of A1 A22 is first diagonality, second diagonality and last diagonality. It will be sum of the principal diagonality. Sum of the principal diagonality is nothing but a trace. Okay, Sum of the base diagonal is nothing but a trace of the matrix. So is subspace, see, 0 matrix 0 n cross n, this matrix has all entry 0, okay, all entry are 0. So if all entry are 0, then you can say it trace will be 0, okay, for the matrix trace will be 0 because diagonal entry are 0. So 0 plus 0 plus 0 will be 0, okay, so trace 0. So 0 matrix, you can say 0 n cross n matrix belongs to V3, okay. So V3 is non-empty, okay, because 0 matrix not to set. Now we are going to prove it is subspace. So we have to take two matrix. Let A and B belongs to Mn, you can say, and two scalar alpha beta belongs to real entity. The scalar field is R, okay. So since A belongs to Mn, from here you can say it trace A will be 0, okay, and also trace B will be 0. Name it on. Now calculate this. Alpha A traces a very nice property. If you take trace of a linear sum, then it is called outside. So alpha trace A, beta trace B. Okay, it is power to trace. You can prove it easily by taking two cosine matrix. Okay, so alpha trace A is 0, beta at 0, so this gives 0. So it is implying alpha A plus beta B belongs to V3 for any scalar alpha. The alpha is arbitrary, so I am taking for, you can choose say for any scalar alpha this hold, and for any AB are arbitrary, that matrix AB are arbitrary, okay, arbitrary matrix and arbitrary scalar. This is arbitrary, and scalar also arbitrary. So you can say for any matrix AB, this will hold Amen. For any matrix AB belongs to Amen, and any alphabetic scalar this will hold. So you can say V3 is a subspace. V3 is a subspace of Amen, right? So option 3 is correct. So you can say option 3 is correct. So option 3 is correct. Now option 4, before equal to BA, such that A will be Amen. Or for B is for some piece matrix. Okay, and this will be subspace or not? See option 4. It is the set B. It is. This member of the set, member of the element will be like this BA, where A is an Mn, n cross matrix which is entire real, and B is some fixed matrix. Some fixed matrix, right? So 0 matrix, this belongs to 0 matrix, A belongs to Z. If I choose A equal to 0, then it is a 0 matrix, okay, each entire 0, and it is a matrix from Mn, okay, and you can see then B into 0, it gives 0, okay, and its member will like BA, okay, so this belongs to V4. So 0 matrix belongs to V4, so V4 is non-empty, okay, this is non-empty set. Now we are taking, we will put this subspace, so we will take two arbitrary matrix. So I am taking two arbitrary matrix, name it, suppose first matrix is B. Here say A will be vary, okay, element will be fixed, but A will be vary. So I will take the matrix like the form A will be vary. So BA1, I am doing C, this matrix, and another matrix BA2, this will be D. Both are matrix from Mn. Sorry, this will be matrix from V4. Okay, V4. This is matrix from V4. And take two scalar. Alpha beta belongs to scalar, and here is field is R. So you take alpha beta R. Now if you make this combination alpha C plus beta D, okay, if you make this combination alpha C whole word, C will be BA1, okay, and beta D will be BA2, okay. So this gives you can take matrix outside, this scalar inside B1, and this gives beta A2, okay. So this gives B inside B1 plus beta A2. Now A and A2 are both is matrix from Mn, okay, n cross matrix which entire real, and it is scalar, then it will be a matrix from Mn, okay, I am name it A, say. So this gives B into A, where A will be this alpha A1 plus beta A2, this will be matrix from Mn, okay. So this, so I can say alpha C plus beta D is form of BA, so it imply alpha C plus beta D. This belongs to V4. Okay, and then imply since it alpha beta arbitrary class, we can told for say for any class for any CD matrix this will hold. Okay, V4. So V4 will be subspace. V4 will be subspace. Okay. So option 4 is also right. So this question option 4 which will be also correct. Okay. So in this question correct option are option 3 and 4. Okay. Hope you understand this question. Okay. And its solution. Okay. So in upcoming videos we will discuss more solution or more solution about the question of subspace. Okay. With in details. Okay. So please follow my channel and subscribe my channel. Okay. This question correct option are option 3 and 4. Okay. So in this question correct option are option 3 and 4 are correct answer. It is multiple MSQ question type. Okay. So more than once correct. So in the question correct option will be 3 and 4. Right. So thank you.